Hello everyone. Now we will take a look at partial fractions. So what are these partial fractions? If two rational functions are given to you as simple as this, right? This 2 over x minus 2 plus 3 over x plus 1. You all know how to simplify as a single rational function, right? Basically, we take the common denominator, we multiply these two together, and then we kind of cross multiply this with this and this with this, so the denominator becomes this one and the numerator becomes that one. Now the question is, how do we do the reverse process? If someone gives you something like this, right, how do we rewrite it in this particular form, right? And that's the partial fraction, right? That is what we call partial fractions. So the partial fractions mainly deals with splitting in the bottom, right? Basically, how do we work with when you have something in the denominator that is factorable or even non-factorable? How do we rewrite it as simple as in the simple terms, in the simplest terms possible, as additions and subtractions? So there are three main categories and there are some subcategories. So there are three main categories. What are those? So when you have that, it only works with the denominator, right? So when you have something like this, so we're going to say p of x over q of x, right? P is a polynomial, q is a polynomial, and when the q of x, again the p of x is p of x, and the q of x has three categories. We can categorize in three categories. By the way, here we assume that the degree of the p of x to be less than the degree of q of x. Otherwise, what you would normally do is you would divide the p of x by q of x, and then whatever the remainder that you have, you're going to work with that. So suppose if the degree of the p of x is smaller than the degree of the q of x, for example, as simple as this: 2x plus 1 over x squared minus 3x plus 2, right? The first thing that you want to do is to rewrite this into the basically factoring the denominator. So if I factor the denominator, I have x minus 2 times x minus 1, right? And here you see that the degree of the numerator is 1, the degree of the denominator is 2, right? So the degree of the denominator is higher than the degree of the numerator. So we are going to work on these kind of problems. So the we always try to factor the denominator and then we solve before we do anything. So now there are three categories. So what are those three categories? The category number one, when the q of x has what we call simple factors. What do I mean by that? It's going to have x minus a, only the denominator, right? Only the denominator, not the numerator. X minus a times x minus b times x minus c, and so on. That's the category number one, or case number one, right? That's a case number one. The case number two is, broadly speaking, q of x have factors with multiplicity. What do I mean by that? The x minus k is not a simple factor. You may have x minus a times squared, or you may have x minus b cubed. You may have x minus c to the 2020, something like that, right? So each of them or some of them have multiplicity. Case number three, or the category number three, is when the q of x have irreducible quadratic. For example, you may have something like this: x squared plus 4. You know that you cannot further factor this, or multiplied by x squared plus 25 and things like that, right? So these are the main three categories, and of course there are other categories, namely combination of all these. So I can always say, for example, what about this? Yes, that's also a possibility. What about this? When the q of x, the denominator happens to be x minus a times x minus b the whole cubed times x squared plus c squared, something like that. You see that now you have all three mixed, right? Now you have a simple factor, factors with the multiplicity, and here is an irreducible factor, irreducible quadratic factor. I may also have various cases. I can kind of extrapolate it, and then you can see that you may have a case where this could be a squared as well. Now you have a irreducible factor that has a multiplicity, right? So how do we work with these things? So let's take a look at how do we work with these things and then so on. So the general idea is the following. We are going to, whatever that you have, right, we are going to, our goal is at the end of the day is to take a look at this and transform this into as simple factors, as simple rational functions as possible, right? That is the idea. So let's take a look at some of these general examples. So here's a case where my pfx, my pfx is p times x plus q divided by x minus a and x times x minus b. Here a should not be equal to b. If a is equal to b, then it's going to be one and the same. So therefore we have factors with multiplicity. So in that case, what do you do? Very simple. You're going to rewrite this as a over x minus a plus b over x minus b. As simple as that. A constant. This is a constant. That's another constant. So it's a over x minus a times the b over x minus b. That's it. As simple as that. So when you have factors with multiplicity, what you do is the following. You're going to say a over x minus a plus b over x minus b is x minus a squared. If this is 3, then you're going to have another c over x minus a cubed and so on. And here you have 3 simple factors. You're going to have a over x minus a plus b over x minus b and c over x minus c. Here you have one with the multiplicity, one without the multiplicity. So for the multiplicity, we're going to say this is a over x minus a plus b over x minus a the whole square, right? And then for this simple factor, it's going to be c over x minus b. Here's a case where you have irreducible factor, a quadratic factor. You cannot reduce them further. Then for this one, you're going to have a over x minus a, and for this one is going to have, you're going to have a bx plus c, not b, but bx plus c over x squared plus bx plus c. So that is the general idea. So let me give you some examples, and then kind of you will see how it is. And then at the end of the day, what we are going to do is you need to figure these a's and b's out, right? The next videos you can see them, right? You're going to figure out the a's and b's. That's what we're going to do. So let's try to decompose these rational functions into simple rational functions, and then we'll see how we solve them later. So let's take a look. So when I have a 5x plus 7, again, I don't care about the numerator as long as the numerator has less power than the denominator, right? This is x times x, so it's x squared. I only have x there, so I'm okay there. So therefore I can apply the partial fractions right away. So again, I'm going to, if I pay attention here, this is a simple factor, that is a simple factor. So what I'm going to say is this is going to be a over x minus 1 plus b over x plus 3, and that's it. That's how we're going to decompose the previous rational function. Let's take a look at the next one, the part b. Now I have, again, the numerator has the power being the squared. The denominator seems like there are 3 simple factors, right? So the power being the cubed. So that's also the power on the numerator is less than the power on the denominator. So we can now do the partial fractions. And so this would be, again, these are all simple factors, 1, 2, 3 of them. So I'm going to say a constant a over x plus 5 plus b over x minus 4 plus c over x plus 6. And now let's take a look at the next one. So here, what you see here is I have a 4. So there's a multiplicity right here. Again, the power on the numerator is smaller than the power on the denominator, so I can work with them. So here what I'm going to have the following. So I'm going to have a over x minus 5 plus b over x minus 5 squared. I'm going to keep on going until I reach the number 4, right? So then I'm going to have a c over x minus 5 cubed plus a d over x minus 5 to the 4, right? So that's how we deal with the multiplicity factors with multiplicity. Now let's take a look at the part D. What you see in the D is, again, there is a one simple factor and there is one factor with the multiplicity. So the way that we are going to do this is we are going to say this is a over x plus 1 plus, we are done with this one now, right? We are done with this one. So we're going to work on this, right? And that has a power being 2. So I'm going to say a b over x minus 2 plus c over x minus 2 squared, right? Because of the square, I'm going to have two constants associated with that. Now let's take a look at the part E. So there's a typo in here. I meant to say this is a plus. I meant to say that's a plus. Please make a note of that. Let me write on a different color so you can see it, right? That's meant to be a plus. So if you take a look at this particular one, you cannot further reduce it, right? You cannot further reduce it. If you really try to find the solution by setting the denominator to 0, you're going to have complex roots. So then how do we work with this, right? The answer for this one is going to be, since I cannot further reduce this one, this is going to be ax plus b, or ax plus b over x squared plus x plus 4, right? And let's do the 7. I also, by the way, this is also plus, not a minus there. And now how do we work with this one? So now we have what we have is, this is really a little bit interesting, fun. You have an irreducible factor with a power 3 and a simple factor, right? Let's take care of the irreducible factor first, then we will deal with the simple factor. So this, you're going to say something like this. You're going to say this ax plus b, because it's irreducible factor, divided by x squared plus x plus 4, plus then you have cx plus d, and then you're going to have x squared plus x plus 4, then you have plus ex plus f over x squared plus x plus 4, and then, sorry, I think here's a squared and here should be a cube, by the way, right? Now I took care of it all the way up to the power 3. I took care of it, right? And so therefore now I'm going to work with this x plus 7. If you work with x plus 7, then I'm going to have g over x plus 7. So that's how we decompose any rational functions into these simple rational functions. Now in the next videos, in the next set of videos, we're going to see how do we find these constants a, b, a, and then in this case a, b, c. In this case we're going to have 4 constants. In this case we're going to have 3 constants. In this case we have 2 constants. In this case we have 1 and 2, 3, 4, 5, 6, 7 constants, right? So we're going to see how do we do that, and then we're going to solve these problems, right? So I will stop it right here. I'll see you all in the next video.